In 7.2, we are going to cover scientific notation. So please, to start off your notes, write down our learning objectives in the top of your paper. So today our objectives are to write numbers in scientific notation and convert between standard form, and to perform operations on numbers written in scientific notation. Before we dive too far into that, I do want to do a quick review of our 7.1 notes, okay, on zero exponents and negative exponents. So in this first example, what I'm noticing is this whole parenthesis is being taken to the 0 power. And if we recall, anything to the 0 power is going to just be 1, okay? And that negative out front is not affected. So that negative out front still stays with it. All right, looking at this next one. All right, the first thing that I'm noticing, this p to the 0, that is obviously a 0 exponent. So 0 exponent is going to become a 1. All right. The other things I notice are all of these negative exponents. This -3, this -5. So remember, negative exponents, those have to move, okay? Remember negative attitude? You're going to be told that you need to move to get a positive attitude. So I'm going to start rewriting all of this, okay? So I have 2m squared. That n is going to move, and the p to the 0 turns into 1. So I could show multiplying by 1 here, but I think you'd all agree that that doesn't need to be shown. Multiplying by 1 doesn't do anything. So on the bottom, I'm going to start off with the 8. Remember that n to the -3 is moving down, so it become a positive exponent. Q to the -5, again, negative exponent, that needs to move up to become positive, needs a positive attitude. Then that -2 squared. Remember, a negative number is not the same thing as a negative exponent. It is actually just fine as is, okay? A -2 squared, so -2 times -2, actually just becomes 4. All right, so I still have a little bit more cleaning up to do. Okay, so I have 2m squared q to the 5. Now on the bottom I have 8 and I have 4. Okay, so 8 times 4 is going to give me 32. So again, right now my goal is simply cleaning this up. Okay, making it look nice. I'm going to combine those numbers that are on the bottom by multiplying them. Now I have 2 over 32. Okay, both of those numbers are divisible by 2. So remember, when both are divisible by 2, you can reduce it. So this is going to be 1m squared q to the 5 over 16n cubed. And again, obviously, you don't really need that 1 there. So you can take that 1 out. Multiplying by 1 doesn't actually do anything. So this would be your final simplified form of that expression. All right, so just a little recap of what we've already learned. Let's talk about where we're going with all of this. So as a little introduction, determine how many times your heart beats in 100 years if it averages 80 beats per minute. All right, we're going to pull out some science on us here, okay? So 80 beats per 1 minute, okay? And I want to convert this into beats per years, okay? Well, that's quite an adjustment, right? So here, I'm going to convert minutes. Well, there are 60 minutes per 1 hour. There's 24 hours in 1 day. There are 365 days per 1 year, and we're talking about 100 years. Okay, so again, this is very science-y because this is how you would track things in science to convert between those units. So this is going to be a massive, massive number. So I'm quick going to pull out my calculator and calculate this for us. So 80 times 60 times 24 times 365 times 100. And I get this number right here. All right. So over 4 billion times in 100 years. So what's the point of this really quick activity? Well, the point is that is a huge number. Okay. So the point of today is recognizing how can I represent really big numbers and really small numbers. Okay. So that can be done with scientific notation. Now, what is scientific notation? Well, scientific notation is just taking a number and multiplying it by some power of 10. Okay? Now, what are the restrictions on this? Well, oh, A must be between 1 and 10. And then the exponent, that n must be an integer. So by integer, I just mean a nice number, like 1, 2, 3, 4, -1, -2. Okay? So those are the restrictions when you're writing something in scientific notation. So what are some examples of scientific notation? Well, some examples would be 2.5 times 10 to the 6th. Okay? 3.49 times 10 to the -7. Okay, so all of those are legitimate ways to write scientific notation. It is some number between 1 and 10 times 10 to some power, okay? And the power has to be a nice number, okay? So first let's talk about why some of these are not in scientific notation. So given this information we just talked about, why these aren't, okay? Now for the first one, I'm hoping you notice this right here. That is less than 1, okay? And remember, scientific notation, the number out front cannot be less than 1, okay? So that rules that one out. This one, that is not an integer power. Okay, so also make sure that that 10 needs integer powers to make this work. And this one, well, this one is just a whole hot mess, okay? There's no 10 to a power. Okay, that one they just put the power on the number itself, and that doesn't work either. Okay, so again, just starting out, giving you an understanding of how this works. Okay, what is scientific notation and what is not scientific notation. So let's take a look at converting between these different forms. Okay, so converting between the forms. The first thing you want to do is recognize this is going to become some number between 1 and 10. So after the first significant digit that you see, envision the decimal point being there, okay? So this is going to become 6.78 times 10 to some value, okay? We need to figure out what that value is, all right? So taking a look at this, right now our decimal place is right there, correct? So let's see how many times we have to move that decimal place. Well, I need to move it 1, 2, 3, 4, 5 times, okay? Because I moved it 5 times, that is going to become a 10 to the 5th, okay? Now also recognize because it is a very large number, that's making a positive exponent, okay? So big numbers are positive exponents, all right? Well, let's take a look at what happens for the reverse. Again, I want you to look for the first significant digit. In this case is 3. So imagine a decimal place right after that 3. So this is going to become 3.2 times 10 to some number, okay? The rest of our goal, figure out where that or how many times you have to move the decimal. What is that number? Well, the decimal is right here to start with. And it's going to move 1, 2, 3, 4, 5 times, okay? But this time, notice we started with a very, very small number. Because I started with a very small number, this time is not actually 5. This time it is -5. All right, let's continue practicing this. So again, I'm looking for the first, excuse me, my first significant digit. In this case, the first significant digit is the 5. So I put that little fake decimal place right after the 5 to recognize this is going to be 5.14 times 10 to some value. And let's find what that value is. So right now my decimal place is hidden right here because it's a whole number. And then 1, 2, 3, 4, 5, 6, 7. It had to move 7 times. And again, because it was a large number, that is a positive exponent. Positive exponents make numbers bigger. All right, our last one. Well, our first significant digit isn't until the very, very end. So here we're just going to have a 7, okay? That's the only digit that we have. Times 10 to some power, okay? What is that power? Well, let's check. 1, 2, 3, 4, 5, 6, 7. But because it's creating a very, very small number, that is going to be 10 to the -7. Okay? So that's how you can take a number and turn it into scientific notation. Okay? The larger the exponent, the larger the number. Or the more negative the exponent, the smaller the number. Okay? What about the other direction? Okay? So what about this? What if I give you scientific notation and I want you to write it in standard notation? All right, well, let's think about this. So here, I'm starting with that 5, 5, okay, and I have my decimal right there. And I need to move that decimal 6 places, okay? Now, moving it 6 places, I'm going to move it 6 in the positive direction, okay? So 1, 2, 3, 4, 5, 6. And anywhere that you see a hole, okay, any hole gets filled with zeros. So this is going to get 5 zeros added onto it. And I'm going to get that for its standard notation. Okay? In the reverse of that, this time I'm starting with 3.1. But this time it's a negative exponent. So when I'm putting it into standard form and have a negative exponent, it's going to move the decimal towards the negative direction on the number line. Okay? So I'm going to move this 1, 2, 3. And same thing, you fill in any holes with additional zeros. Okay? So this is going to become 0.0031. Okay, so again, pretty conceptual, but just making sure that you keep those rules straight. A positive exponent means move it in the positive direction to write it in standard notation. Negative exponent means move the decimal towards the negative direction. Now, this one is not in your packet, but I think it's kind of a fun little challenge problem. Okay? So, here, this is not proper scientific notation. Okay? To be proper scientific notation, this can't be above 10. So remember, you take that first significant digit, and that's where your decimal goes. Okay? So, now we need to think, we moved our decimal, didn't we? Okay, so in moving our decimal, what is that going to do? Well, 45 is bigger than 10, right? So because 45 was bigger than 10, it is going to positively contribute to the exponent, okay? So again, because this was bigger, in order to put it in proper scientific notation, it's contributing positively to the exponent. So I moved the exponent once over, so that's going to contribute one more to the 10, okay? So that's kind of a fun thing to know as well, how to adjust if it's already written in kind of a pseudo-scientific notation, how to adjust it, okay? Every time you move the decimal, it just changes the power of the 10, all right? All right, what about comparing these values? So comparing numbers in scientific notation. So I kind of noted before that the larger the power of the 10, the bigger the number. The smaller the power of the 10, the smaller the number, okay? So if I'm trying to order these from least to greatest, okay, I'm looking at this, I see times 10 to the 7, times 10 to the 7, times 10 to the 8, times 10 to the 8. So when I'm putting them in order, again, the smaller exponents are going to be smaller numbers, okay? So my first focus is going to be on the ones that are 10 to the 7, okay? Because those are automatically smaller than the ones that are 10 to the 8. So looking at that, well, once I have those two grouped by the power of 10, well, then the smaller one is just the one with a smaller main number, okay? And again, I think most of this is pretty, oh, I'm sorry, that should be a 7. Most of this is pretty conceptual. So now that I have those, now I'm going to focus on the ones that are 10 to the 8. All right, and 1.06 is smaller than 1.8. So there they are in order from least to greatest. All right, I apologize. Last concept for today is talking about multiplying in scientific notation. Okay? So when you multiply in scientific notation, the note that you need to put here is you only want to multiply to the main number, okay? Nothing happens to the power of 10. So when you multiply the 3 to the 5.4 times 10 to the 6, the 3 is only multiplying the 5.4, okay? It's only affecting the 5 to the 4. It doesn't change the power of the 10 whatsoever. Only multiply to the main number. But now I have some adjusting to do, okay? And this is kind of why we did that first challenge problem on the last slide, because it leads directly into this. So here, if you notice, this is not between 1 and 10. It needs to be this. So I need to move the decimal 1 over. Now notice I'm starting with a large number, okay? Starting with a large number, a big number, is going to contribute to make that power of 10 bigger. Okay, so in moving that decimal 1 over is going to increase my power of 10 by 1. And what about this next one? Okay, so 2 times 9.8 times 10 to the negative 5. Well, 2 times 9.8 is 19.6. And again, at this point, it's not influencing the power of 10 at all. When you multiply that number, it only multiplies into the main number. But again, probably you'll notice, just like last time, that this is no longer between 1 and 10. I need it to become this. I need to move my decimal over once. Well, again, this is larger than 10, so it's going to contribute positively to make the power of 10 bigger because it was bigger. Well, this time you have to think really carefully, okay? So negative 5, and I'm adding 1 to that, okay? So again, here be careful since it's a negative exponent. When you make it bigger, that's actually making it closer to 0. So negative 5 plus 1 takes you to negative 4. Okay, and just be very careful that you recognize that, please. All right, so that is all for today's notes. Now, same as always, I want you to look at that little summary box. So today we had two objectives: to write numbers in scientific notation and convert between standard form, and to perform operations on numbers written in scientific notation. So I want you, same as the first notes, write a couple sentences summarizing some of the things we talked about. This one, there's some good stuff that I didn't explicitly write in the notes necessarily, but that would be good for you to write out to help you reflect and remember what that process looks like. Okay, so take a moment to do that. Please rate yourself from 0 to 4. Again, 3 is at mastery. That's where we want you to be. 1 and 2 mean you're working on it, you're getting there. 4 is above and beyond. You think you could be doing more than what I'm expecting. So thank you for doing that, and I look forward to seeing you in class.